Thank you. I'm Dr. James Maisel. I'm with Zydoc. We work in a number of areas, and I'm going to specifically concentrate on natural language processing and computer-assisted coding, and how we take natural language processing and apply it to the day-to-day work of the radiologist. One of the definite directions that medicine is heading is towards structured data, and radiologists are used to dictating and having unstructured data. So we've got to have some paradigm change here. CPT-4, ICD-9, ICD-10, RxNORM, SNOMED-CT, and LOINC are the emerging standards for data. And we want data in that structure so that we could do data mining for outcomes, utilization, quality assurance, and answer questions for research and economic reasons also. This data structure will be required. It is mandated for EHR, ICD-10 for October 2013, and SNOMED-CT will be the clinical terminology that's required in EHR. And the reason why these are mandated and desirable is for interoperability. So we can exchange data between diverse systems, be they EHRs or PACS or RIS systems, and be able to do this type of analysis there. So interoperability actually is driving this, and the need to take that coded data and move it between diverse systems. Once the data is coded, it's very easy to move it between RIS and PACS and EHR, HIEs in standard architectural formats like CDAs, CCR, CCD documents, or with HL7. And you can take coded data and move it into billing and also analyze it very efficiently from a relational database. So what's the problem with structured reporting? Well, how many people use structured reporting now out there? Okay, and does anybody find it more efficient than dictating? Probably only if you have a normal exam. If you have any pathology in the exam, you have to click through a lot of fields. So structured reporting is a definite change in work habits. Radiologists are used to looking at images and dictating while they are looking at the images. Entering structured data in a computer program requires you to look away from the image, and it requires you to navigate through menus. And it takes a lot of time to enter structured data because you have to go through a lot of menus. And if you think you have a lot of drop-down choices now, in October 2010, when your ankle fracture will go to over 200 codes in ICD-10, you're paging through a number of specific choices. So you're going to have a choice between spending a short amount of time dictating or a long amount of time entering data. The compromise is you enter less data, so we have limited amounts of structured data. So entering the data is very inefficient in structured format, whereas dictation is much more efficient. So radiologists are very fast dictators. We work in the transcription industry, and radiologists are over 140 words a minute. Quite often have to slow it down to actually understand and type it. So you could generate a 419-word document, report of a PET scan, in 3 minutes very efficiently. And the doctors that do this day in and day out are familiar with the format, and they know what to include and not include. Direct entry into an EHR or a structured reporting system in a PAC system might take 10 minutes for a case with pathology. If you're an interventional radiologist, good luck. So why can't you dictate directly into these systems, into your EHR or PAC systems with speech recognition? Well, certainly you could, but the problem with that is it generates free text, which is not structured, and you can't data mine it. So you're left with this dilemma: do you work efficiently, or do you capture structured data requiring extra time? So we chose to look at using natural language processing as a solution here to give you the best of both worlds. You capture the documentation efficiently using dictation, and then you take the free text and you convert it into structured data using natural language processing. We can generate SNOMED-CT, LOINC, RxNORM drug codes, ICD-10, and certainly ICD-9 and CPT-4 for billing out of one dictation. So what does natural language processing do, and how does it work, and what's a document look like? Well, on the left would be a typical dictation of a physician. The yellow terms are the ICD-10 coded terms that are extracted and put in a database, and I'm just showing you this in a simple application so you could see. So these codes on the right are actually the ICD-10 codes that are extracted. These are the headings for physical examination, assessment, and plans that allow insertion into an electronic record or other system. When we go to SNOMED coding, SNOMED is the clinical terminology. The yellow terms are the SNOMED terms, and the blue terms are the modifiers. Pertinent negatives are also picked up here with no. So you can see for a different descriptor that you may have dementia and have 3 qualifiers of it. You can have up to about 28 modifiers of any SNOMED concept. SNOMED is beautiful because it gives you hierarchical structure. So you can pull out all brain tumors or a specific type of brain tumor and go drill down to very narrow specific pathologies to pull out data later on from the database. So natural language processing is very efficient. We're seeing that we could pull out codes at about every 1.5 seconds of dictation generating the code. Now imagine if you had a structured template where you have to go down and click there every 1.5 seconds to generate codes, and it's just amazing how many codes are pulled out of a transcript, out of text. You can also take other forms of medical information and feed it into these systems, from EHRs that are semi-structured or legacy documents, and feed them in virtually any standard input, pre-process them and feed them into the NLP engine. So what I'm showing is an efficient solution that allows you to continue to work as you do with no change in habits with dictation, and whether you use speech recognition on the front end or transcription or legacy documents, feed those into the NLP engine and then output them into structured format along with the narrative that is really what the physicians want to read to see what's going on. So the workflow involves the physician dictating on the top left in one, and this could be with live speech recognition, back-end speech recognition, or conventional transcription. Nobody really cares. You're taking this text document and then you're submitting it to the NLP engine for processing. And this technology then forms the data structure within a database. It has the text corresponding to the codes that are extracted in XML format. We've done this in Microsoft SQL 2008. And you could subject that to queries for research outcomes, serious adverse effects, or you can pull out messages, CDA messages, and send them to an EHR, or do automated coding for the billing, all with just dictation. Thank you.